Hello, everyone. Welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this class, we will explore the key factors that influence the hazards associated with hazardous chemicals. First, let us examine one of the primary characteristics of hazardous chemicals that leads to accidents: flammability and explosiveness. Under normal temperature and pressure conditions, hazardous chemicals can ignite or explode when exposed to ignition sources such as impact, friction, heat, or sparks, with the severity of combustion or explosion depending on the chemical composition of the substance. Generally speaking, gases are more flammable and explosive than liquids or solids, and they burn at a faster rate. The second characteristic is diffusibility. In chemical accidents, spilled substances can spread to the surrounding area. Flammable gases, lighter than air, can disperse rapidly in the atmosphere, forming mixtures with air and drifting with the wind, causing combustion, explosions, and the spread of toxic effects. Substances heavier than air tend to accumulate on the ground, in ditches, and in corners. If they accumulate over a long period without dispersing, they can lead to delayed combustion, explosions, and cause personal poisoning. The third characteristic is suddenness. Accidents caused by chemical substances often erupt suddenly, posing a hazard within a very short time or even instantaneously. Many chemical accidents involve the leakage of high-pressure gases from containers, pipelines, and other equipment. Due to the nature of high-pressure gases, a large volume is released in a short time, rapidly turning vast areas into contaminated zones. Once hazardous chemicals catch fire, the blaze often erupts violently and spreads rapidly. Combustion and explosions occur alternately, and coupled with the dispersion of toxic substances, they rapidly cause harm. The fourth characteristic is toxicity. Toxic chemical substances enter the body through one or more routes. When they reach a certain concentration, they can cause structural damage to the body, disrupt normal physiological functions, and lead to poisoning. So, what are the main factors influencing the hazards of hazardous chemicals? The hazards of hazardous chemicals are related to their inherent properties. The physical and chemical properties and states of a substance can indicate its hazards. There are primarily three aspects to consider: the relationship between physical properties and hazards, other physical and chemical hazards, and the risk of poisoning. Let us first examine the relationship between a substance's physical properties and its hazard level. First, the boiling point refers to the temperature at which a substance transitions from a liquid to a gaseous state under a standard atmospheric pressure of 101.3 kilopascals. Substances with lower boiling points vaporize more rapidly, making it easier for them to quickly cause high concentration air contamination at the accident site and reach the explosive limit. 2. The melting point refers to the temperature or range of temperatures at which a substance melts under standard atmospheric pressure. The melting point reflects the purity of the substance and can be used to infer its distribution in various environmental media such as water, soil, and air. The melting point is relevant to decontamination at the contamination site and the handling of pollutants. 3. The relative density of a liquid is the ratio of the substance's density at 20 degrees Celsius to the density of water at 4 degrees Celsius. In the event of a fire involving a liquid with a relative density less than 1, extinguishing the fire with water is ineffective because the water sinks below the surface of the burning liquid, and the flow of water actually causes the fire to spread. 4. Vapor pressure. Vapor pressure refers to the pressure of the saturated vapor of a chemical substance at a given temperature when it is in equilibrium with its liquid or solid phase. Vapor pressure is a function of temperature. The higher the ambient temperature at the time of an accident, the higher the vapor pressure of the chemical substance, and its concentration in the air increases accordingly. 5. Vapor relative density. This refers to the ratio of the vapor density of a chemical substance to the density of a reference substance under specified conditions. According to design codes for explosive hazardous environments and electrical installations, gases or vapors with a relative density less than 0.8 are classified as lighter than air, while those with a relative density greater than 1.2 are classified as heavier than air. Gases lighter than air tend to rise toward the ceiling or escape from open windows. Gases heavier than air tend to accumulate near the ground after a leak and can spread over considerable distances at lower elevations. If the gas is flammable, it may ignite and cause a backfire at a distance when exposed to an open flame. For example, the relative vapor density of vinyl chloride is 2.15 in the major deflagration accident at Hebei, Shanghua. On November 28, 2018, vinyl chloride leaked from a gas holder and spread along the ground outside the plant premises, where it encountered an open flame on the road, resulting in the deflagration. S6. The relative density of a vapor-air mixture refers to the density of the vapor-air mixture present above a liquid or solid in contact with open air, relative to the surrounding pure air. A relative density value is greater than or equal to 1.1. This mixture may flow along the ground and accumulate in low-lying areas. When the relative density is between 0.9 and 1.1, it can mix rapidly with the surrounding air. As 7. Flash point, the lowest temperature at which flammable vapors released above the surface of a liquid, when fully mixed with air at standard atmospheric pressure, can flash ignite for 5 seconds. Chemical substances with a lower flash point are more likely to form explosive mixtures in the air after a leak, leading to combustion and explosions. 8. Autoignition temperature, the lowest temperature at which a substance will ignite or undergo spontaneous combustion upon contact with air. At this temperature, the substance may continue to burn even in the absence of an ignition source. The autoignition temperature is critical for selecting electrical equipment for use in spaces where explosive vapor-air mixtures may be present, and it is also crucial for determining appropriate process temperatures. 9. Explosive limits. This refers to the concentration range within which a mixture of a flammable gas or vapor with air can ignite or cause an explosion. It is generally expressed as the volume fraction of the flammable gas or vapor in the mixture. The lowest concentration is called the lower explosive limit, LEL, and the highest concentration is called the upper explosive limit. Note that explosions will not occur if the concentration is below or above this range. Factors affecting the hazard level of hazardous chemicals also involve other physical and chemical hazards. Liquids with a resistivity ranging from 1 × 10 to the 10th to 1 × 10 to the 15th ohm centimeters. Static electricity is easily generated during flow and agitation, which can cause fires and explosions. For example, static electricity must be prevented during the loading and unloading of gasoline and diesel. Some flammable chemical substances, when in powder form or as fine particles smaller than 0.5 millimeters in diameter, can mix thoroughly with air and, upon ignition, may cause combustion or explosion. This is known as a dust explosion. Polymerization reactions typically release significant amounts of heat, causing temperatures to rise rapidly and accelerating the reaction rate, which poses a risk of fire or explosion. Some chemical substances produce toxic gases when mixed with other substances or when burned. For example, the combustion of nearly all organic compounds produces toxic gases, such as carbon monoxide. In addition, strong acids and strong bases often undergo violent reactions and cause corrosion when they come into contact with other substances. Factors affecting the hazard level of hazardous chemicals also include the risk of poisoning. In sudden chemical accidents, toxic chemicals can cause personnel to become poisoned. Examples include hydrogen sulfide, chlorine, and formaldehyde. In this lesson, we have learned about the main characteristics of hazardous chemicals and the factors that influence their hazards. That concludes this section. For your homework, please consider the following question. How can we analyze the hazards of hazardous chemicals using their physical and chemical properties? Alright, that concludes this session. See you in the next class.